Hello everyone, welcome to my channel. In this video, I will explain about linear discriminants. Okay, so what is the meaning of linear discriminants? Linear discriminant analysis is a dimensionality technique that is used for supervised learning classification problem. So please remember all of you, when we say principal component analysis, that is the unsupervised learning. But when I say linear discriminant, this is called as supervised. We are using labeled here. It is used for modeling differences in groups. Okay. So to separate two or more classes, you observe here we have the graph is there. Let us say the graph is x1 or else we can say x-axis. So this is a y-axis. So there is a line is there. This data is going to separate the data between these values and these values. So what is going to be happened here? The goal is to find a linear combination of features that maximize the separation between different classes while minimizing the spread within each class. Okay. So in the linear regression, so in the linear combination of features, in the linear discriminants, what is going to be happened? We are going to maximize the separation between different classes. So we are going to maximize the separation between different classes, minimize the spread. Okay. So we have two things are there. First one is we need to maximize the mean difference. Second one is we need to minimize the within class scatter. Okay. So now we'll discuss about the steps. So what are the steps included in linear discriminant analysis? So completely there are 7 steps are there. So first one is the calculate mean values of each class and compute a covariance, compute within class scatter matrix, and fourth one is the compute between class scatter matrix and find the eigenvalues, choose top eigenvalue, find the eigenvectors, and last one is the find dot product of each with eigenvector. So these are called as important points, or else we can say algorithm to complete the linear discriminant analysis. Now we'll see the example. So you can observe on the screen, the example is compute the discriminant analysis, compute the discriminant projection for the two values on the screen. You observe, so the values are here 4, 1, 2, 4 and so on, and these are called as x2 values. So directly I will explain this example. By the way, you will get more clarity about the linear discrimination projection. So first we need to compute the mean of class 1 and class 2. So what is the meaning of class 1? Remember all of you, in this this is called as class 1, it is called as class 2. So S1 plus S2. So how to find out this one? Mean mu1 is equal to mu1, but first class you observe 4 plus 2 plus 2 plus 3 plus 4. So 4 plus this is 3 comma 3.6. So how we receive this one? 1 plus 4 plus 3 plus 6 plus 4. So this is called as 3 comma 3.6. So when we have this mu1, so first mu value is 3 comma 3.6. So after completion of this one, we are going to subtract this value. Okay. So x comma x minus mu1. So you see here we are going to subtract the value. This is 4 minus 3, 1, 1 minus 3.6 minus 2.6. This is 2 minus 3 minus 1, 4 minus 3.6, 0.4. So this is called as x minus mu1. Similarly, remember here we are finding the value called as SW is equal to S1 plus S2. So in order to find out S1 plus S2, the formula is this one. So S1 is equal to sigma of x minus mu1, x minus mu transpose. So in this, we already completed this x minus mu1, that is equal to this value minus 1.1 minus 2.6 and so on. So you see minus 1.1 minus 2.6 minus 1 0.4. So 2.4 1 0.4. So we take all the values of this one and transpose. So this is called as transpose. So minus 1 0.4 minus 1. So when we interchange the values columns with rows, these are called as a transpose values. So when we do the multiplication with this, we receive these values. Okay, so this is called as a S1. So similarly, the final answer for this S1 is, so when we do multiplication with all the values, the final answer for S1 is this one. And mu2, so we completed mu1, or else we can say this is a S1. So in order to do this S2, similarly we do same procedure. So first we need to find out the mean value, then we need to find out all the values of this one. Okay, so again we are going to subtract the values with the x2 mu2. So what is the value of x2 values? X2 values are 9. So 9 is subtracted with this value, this one 8.4, that is 0.6. Second one is the in this 6. So 6 is subtracted with this 8.4. So when we do all this, we get same whatever the things happened for S1, we do same calculations here. So when we do this one, the final answer of this S2 is this one. So what is the formula? We are going to do, the formula is equal to SW is equal to S1 plus S2. So S1 value is this one, S2 value is this one. The final answer for this SW is here. Okay, so you may not get any confusion. Whatever the procedure available we do for S1, same thing will be happen to S2 also. Second one is the compute the class scatter matrix. Okay, so here you observe SB is equal to formula mu1 minus mu2, mu1 minus mu2 transpose. So we need to find out the value of starting. We will find the mu1 minus mu2. So the answer is, so already we completed in the above mu1 and mu2. So that is 3.6 minus, so we receive this one. Okay, so what is the formula this one? Mu1 minus mu2, mu1 minus mu2 transpose. So when we have minus 5.4, minus 4 is a value, just you do the transpose. So the final answer of this one is 29.16, 21.60 and so on. So third one, now we'll do the LDA projection vector. So when we find the projection vector, so please remember all of you, this is the formula to find the projection vector. SW dash SB V is equal to lambda V. Okay, so this is equal to, we can also write as modulus of SW dash SB minus lambda I. Okay, so now we have already received this SW value. What is the SW value? So SW value is 2.64 and this one. So simply you write this value here. Yes, you will write here. Then into, so this SB value is 29 point, you write all values as it is, minus lambda I is equal to 0. So when we do multiplication, we get this value. And after completion of this one, what you have to do? You need to do the, remember when I say I, this is called as a vector, the value, the matrix is 1 0 0 1. Okay, so this diagonal values are 0. So this is called as a eigen matrix. So when you say I, the value could be here 1, the matrix 2 by 2 matrix value is 1 0 0 1. So when you do this one, we can do the multiplication after completion of this one. After completion of this calculation, we receive this one. So similarly, we can do here minus 11.89 minus lambda into this one. So we'll do cross multiplication here. So finally we get the values as lambda 1 is equal to 15.66, lambda 2 is equal to 0.99. So remember, when you do here 11.89 89 and 5.08, yes, this value. Then 8.81, 3.79. So we need to add in this. In order to find out the final values, we are going to add one vector. So the vector is equal to v1 and v2. So this is equal to 15.66 v1 v2. So what is this one? Actually there are two values are there. So lambda 1 value is equal to 15.66, lambda 2 value is equal to 0.99. Always we need to select the maximum value. So the maximum value could be 15.66. So we need to add vector that is equal to v1 v2 and v1 v2. Actually this is a given formula we have. So this is a formula. Okay, so we need to add in this. So why we add this v1 v2? Because of this v. Okay, so after we completed all this, so for this v we added this. Also we have v is there. For this v we have added in this v1 and v2. Okay, so remember all of you, after completion of this one, when you do the calculation through calculator or manually, so you get v1 v2 values are 0.91, 0.39. So this is about the vector values, that is 0.91, 0.39. So finally we can directly written as so many textbooks they have mentioned like this only. So finally the directly we can write as W star is equal to SW dash M1 minus M2. So that is equal to 0.91, yes, 0.91, 0.39. This is inverse is there. So we mentioned in this 0.91 minus 0.39 transpose. So this is all about the this is the final value. So this is all about the linear discriminant analysis. Okay, thank you for watching this video. Please subscribe my channel. Thank you.